So now I'd like to introduce our next expert, environmental engineer Elin Betanzo from Safe Water Engineering. Elin has over 20 years of experience working on drinking water science, engineering, and policy issues. She's the founder of Safe Water Engineering, LLC, which is a consulting firm working to improve access to safe drinking water through engineering. In August of 2015, Elin played a critical role in uncovering the Flint water crisis that Dr. Anderson just spoke about, and she worked directly with that doctor, Dr. Hannah Tisha, to conduct a study that discovered elevated levels of lead in the children in Flint, Michigan. She continues to work on lead and drinking water policy at the federal, state, and local levels. So thanks so much for joining us today, Elin.
Hi, thank you for having me. I'm looking forward to sharing my slides. And let's see if that's working the way. Does it look like a slide?
It looks perfect.
Okay, thank you. I live in Michigan. I've been working in Michigan, and we've been working on water quality in our schools for a few years, looking at an approach to get lead safe drinking water in our schools. And we call this the filter first approach. And so I'm going to talk about drinking water and our schools and what my experience has been in Michigan. And so we've got, as Dr. Anderson just reviewed, there's so many sources of lead exposure. But one issue with water is we need to drink it every day to survive. And so it's one of these things, if you're getting lead through your drinking water, you can be consuming it every day. It could be in your home, in your school. And that's why it's very important to address this exposure and prevent it as much as possible. Unlike most of our drinking water contaminants that are usually in our source water and we can remove them at a water treatment plant, lead is rarely found in our source water. Lead typically comes from plumbing materials and lead service lines. And when the water passes through those plumbing materials containing lead, the lead leaches into the water and then we drink it in our glass. So in individual homes, the source of lead is frequently lead service lines. It can also come from household plumbing, fittings, and fixtures. In schools, the service lines tend to be larger because these are larger buildings, larger capacity. So lead service lines are not quite as frequent in schools, but we can find them especially in in-home daycares and smaller school buildings or schools with multiple service lines. But the lead in schools primarily comes from plumbing and fixtures. And so the lead in school plumbing can come from a variety of different sources. And we have what's called this definition of lead-free plumbing. And it was revised in 2014. After 2014, any plumbing materials that were installed had to meet this new definition of lead-free, which means it contains 0.25% lead by weight or less. And so you heard that right. Lead-free plumbing actually, by definition, contains lead. But up until 2014, plumbing materials could be marked lead-free and contain up to 8% lead by weight. And that is a lot of lead, and that still exists in our schools today, and it leaches into the water. Lead solder was banned in 1986, but lead solder is still used for a variety of other applications, and we still see it cropping up here and there in plumbing applications. So it is possible for lead solder to be improperly used in drinking water applications still today. As I said before, there can be lead service lines, but they're not quite as frequent in schools as they are in individual homes. Plumbing materials not intended for drinking water use. If plumbing materials weren't intended for drinking water, they can have any level of lead whatsoever. There's no limits on it. So think laboratory faucets, hose bibs, garden hoses. If they're filling the water coolers for the football team, don't do it through a hose bib and a garden hose because those materials could contain very high levels of lead in them. We also find lead in schools in pre-1988 drinking water coolers with lead-lined tanks. So at our water treatment plants, many of them use corrosion control treatment, and that is intended to reduce the amount of lead that dissolves into the water. It forms a protective coating on the plumbing materials, and the water has to keep passing through those plumbing materials to be effective. A lot of our schools have intermittent schedules, and so that corrosion control doesn't build up the way it does with regular water use like we have in our own homes. So think weekends with no water use, week-long school breaks, no water use, month-long summer breaks with no water use. When you keep interrupting the flow of water in the school building, it means that corrosion control coating cannot build up and protect students from lead in their water. And what that we find is when we test for lead in school water, we tend to find it. And so I'm presenting some data here that I did not have to go far to find. It's actually from my own children's elementary school here in Birmingham, Michigan. The school district decided to do a voluntary lead sampling program, and it illustrates a lot of concepts about lead in water. Lead release in water is sporadic. A one-time test doesn't tell you everything you need to know about the risk of lead from an individual location. And just replacing a fixture doesn't necessarily get you the safe water that you want. Where I'm looking at the American Academy of Pediatrics recommendation of 1 part per billion. So back in 2016, we took a lot of lead samples in this elementary school building where both my children were attending at the time. And but at the time they were looking at a trigger level of 15 parts per billion. And in their first round of sampling, they found that the majority of these sites had a lead level lower than that. They selected a handful of sites to do resamples. And as you see here, 4 sites tested higher in the repeat sample, a few sites tested lower. But one of these sites, really pops out. Its original sample was at 6.3 parts per billion, and then it retested at 140 parts per billion. Same faucet, no change, a high, very extremely concerning level of lead. They replaced that faucet, put a brand new post-2014 lead-free faucet in there, and they still got a sample back at 3.5 parts per billion. So that's not the response that we want. We want to get that lead as low as possible, especially when our children are drinking it every day. And so that's why we're looking at the filter first approach in Michigan. We actually have bills in Michigan. They've passed the Michigan Senate. We're waiting for them to get passed in the House. We have funding to install filter stations in our schools. And so a filter first strategy focuses on providing safe drinking water first, provide the safe water now, and then rely upon testing to ensure that those filters are working and make sure there's a maintenance plan. So it's installing filter stations at a ratio of 1 to 100 students, making sure that there is a plan for maintaining those. The filter stations need to have certified filters that are certified to meet NSF standard 53 for lead reduction and standard 42 for particulate removal. And so in Michigan, the bill that we're working on right now is having testing once per year after the filters are installed to ensure that they are performing as intended and meeting all those certification requirements. And then there's some triggers with that sampling. If something goes wrong, there's remediation if the filtered water still contains lead. Now, in my school district, we've actually been able to implement this filter first approach, and we have filtered bottle fillers in all of our schools where that's where the kids drink their water. We still have taps for hand washing, but those are for hand washing only. We're managing a much smaller number of drinking water outlets, and every single water sample since they've installed the filter stations have been non-detect for lead. We did a cost analysis for the Michigan plan. And what we found is that providing safe drinking water first using the filter first approach actually costs less over 10 years than continuing to sample, trying to replace faucets, and hoping that the kids get safe water. With a filter first strategy, we know we're getting safe water because we know that the water kids are drinking is filtered. But as you can see here in this cost presentation, the this 10% bar here is if we're testing water taps throughout the school and then replacing about 10% of faucets per year, trying to get rid of the lead. And then this cost bar is if you're replacing 40% of fixtures per year to try to get rid of that lead. And so I find this pretty compelling that it costs less and it provides an immediate source of safe water for children to drink in their schools. So we're hopeful that that will get passed this year, and we'll be able to move forward to have that available for all the schools in the state of Michigan.
Awesome. Thank you so much, Elin. And that's great to see Michigan moving forward with a filter first bill.